Okay guys, here's the video for the last, I would say, 2 weeks. We're going to do an extra video after this as far as approaching AI movement in a different light. So just as a disclaimer, none of the artwork is my own. This is all from the game Cuphead. So I'm just using these sprite sheets because I'm essentially too lazy to create my own. So I'm just going to use them. So what we did in the last video is we set up the character movement here. So I'm just going to push play just to show you what it looks like. This little red guy is just a duplicate of the player. Sorry, I'm getting an error apparently. Okay, I'm getting an error where? Apparently it's on the enemy, so I'm just going to delete this enemy and just essentially duplicate and show you what I did. So that should get rid of the error. I'm also going to remove the script that I created for the enemy. Okay, now let's just test it again just to show you where we are. We created the blend tree so that when you go up, it'll move up. When you go down, it will walk down, left and right. And all I did was parent the camera directly to the character just so that I could see the character move around them. So all I'm going to do now is just essentially duplicate the player, remove the camera from the new player, and I'm going to call this enemy top down or TD. Okay. I'm also just going to make sure that I have got remove the variables. Okay, sorry, remove the flow machine, therefore by being able to remove the variables, we're going to use all the pre-existing, actually I'm not going to remove those, being dumb, we're just going to use that pre-existing code and work with it on top. So this is what the code looks like. And I'm just going to break this update so that none of this stuff breaks the testing process for us. And I'm now going to just change the sprite color, so I just have something that's a little different. So I'm going to go for something a little more blue. I'm just going to offset him to the side so that he's there. All I've done is created 4 empty game objects. I'm going to create those again just to show you. Create empty, and then I'm just going to go to my top view so that I can just kind of place these in relation to where I would like them. So let's say I'll put the first waypoint to the left here. I'm going to rename it WP for the first waypoint. Then all I'm going to do is just keep duplicating it as many times as I need it. There we go. There we go. And those are the 4 circled waypoints that I'll be using. I'll just create a new empty game object and just put the waypoints in here just for management purposes, just to keep the filing of these a lot cleaner in this scene. Okay, so let's make this little guy move and play the animations, because we're just essentially using the character controller and we're just going to use what's already been set up in the previous video. We've got all the waypoints that we want the enemy to go to, so we're good to go. I'll show you a few issues we're going to get and then we'll rectify them as we go, but for now we're just going to leave them as it is so we can see the issues we have. Now we're going to be using navmesh. That's why I've kept this project as 2D. So we need to add component a navmesh agent. We're also just going to want to tweak. If you look really closely here, I'm going to go into wireframe so you can see it. This little circle needs to be around the player, so there's an offset base here, so I'm going to put that to 0 so it goes around there. Also just going to change the radius so it just encompasses the player but not huge, and then the height makes no difference because we're not using height being a top-down game, so we're just going to do that. So now that the navmesh agent is in place, this is the brain of the AI that's going to tell it where to go. I'm just going to put a different color material on this background so it's not so glaring and so bright in your face. Create a new material. I'm just going to call it floor. I'm just going to go for something a little darker with absolutely no rough smoothness or metallicness, just so that it's flat. Probably going to go for a gray, deep gray here. There we go, just so we can see things a little bit better on the video. Okay, so let's select our little enemy and we're just going to go through everything we've done before. I'm just going to grab this update. We're going to bring it up here. Okay, so a few things we need. We are going to require a variable. We're going to require a list, so I'm going to call this waypoint list so that I know it's a list. And it's just going to be a list of transforms because all I care about is the position of where these waypoints are. That's all I need. So, sorry, let me just type in list transform. There we go. So, and then you'll see there's a little plus that shows up that it's a list. We're going to make it a static list, so I'm going to add in the waypoints manually. As you can see, I'm adding each waypoint. Don't make a difference if you put them in order. It makes no difference really. I just like to put in order to appease the crazy god in my head. Okay, another thing we need to do is create a variable which is going to be an integer, and I just call it current index, which we're going to use to tell the list where we are in this list, starting at 0, going 1, 2, and 3. So we just need to have a variable that just keeps that in check. So currently it's set to 0, which means it's going to select the first waypoint. So from the update, I'm just going to add a sequence because a certain amount of a sequence of events that I want to happen. And there are going to be 3 sequences of events that I would like to happen. And we're going to start with keeping it simple. We're going to start at the top here and then we'll connect it in. We need to get the remaining distance, navmesh remaining distance. So what I want to do is check if the AI is where they need to be. If they are, we're going to update which part of the list they're going to go to. So from here, we're going to say less or equal to. And then from here, I'm just going to use the stopping distance. So I'm going to use the stopping distance from the navmesh agent, which if you're wondering where that is, go to the enemy, close this up, go to the navmesh agent. You'll see there's a stopping distance. What this means is, I'm going to just drop this speed down a little bit. This means that this is the distance that it will stop in relation to where it's going. So if I put in 1 unit, like I'm going to put in here, he's going to stop 1 meter away from whatever the target that he's going to. So if you're making a ranged enemy, simple enough, just put that as 10. So when he gets 10 meters away from the player, he can start attacking or whatever it is. So I'm going to put this as, let's even put it at 0.5. So we're checking where he is in relation to the target, and if he gets within 0.5, so half a meter from the target, he's going to change to the next waypoint. So as you can see, it's a purple little dot, which means it's a branch or an if statement. So we're going to drag out. We're going to go if this is true. All we're going to do is grab this new current index, drag out. We're going to go add. So we're going to add 1. So from the B, I'm just going to do a int literal. And all I'm going to do is just add 1. That's all we're doing in this state is, and then all we need to do is set this back to the current index. So holding down Alt, grab the variable from the variables section, and it will get a set variable instead of a get variable, and then we'll be able to set that variable. So all this does here, I'm going to plug this directly into the first one. I'm going to hold down Control and drag a group around it. We're going to call this next waypoint index. So all we're doing is getting the next index in the current list of waypoints or adding the next waypoint index to be exact. There we go. There we go. Just making nice and neat. Apologies. Okay, so the next one now is what happens when the list runs out, which means there are currently 4 items in this list. When this index becomes equal to this or greater, we need to reset it so it can go back. So all we do to the beginning, so we can have a continuous loop of the AI going from 1, 2, 3, 4, then going back 1, 2, 3, 4, and so on. So what we're going to do now is we're going to grab the waypoint list. We're going to do count. We're going to get count items. Cheapest, sorry. It's a new feature with a new Unity along with Bolt, and we're going to say if this is greater or equal to, and what it doesn't need to be greater or equal to the current index, to create a branch again, as you can see from the purple node. We're going to plug that directly into the one slot, like this. Just move this up a little bit, make some space. And all we're going to do in here is we're just going to reset this current index. So holding down Alt, drag it out to get the set variable, plug that to the true. And when a variable goes orange, when a node like this goes orange, it means that there's no input value, which means this variable is null. So we need to drag that out, say int literal, and we're just setting it to 0. So we're going to create another group around this stuff. And we're going to say reset index to 0, because that's what it's doing. It's resetting the index to 0. Okay, now that we have all the systems or the logic behind it, we just need to actually get this to move the character. And that's simple enough. Drag from the last sequence, type in agent.setDestination. And now we need a target, and that's simple enough because we've got the waypoint list and the current index. I'm going to copy those two down here, Control C and Control V. And I'm going to drag from the list and say get item. And let's get list item at what index? At the current index that we have. And from here, all I want to do is just get its position. So transform.position. And we're going to plug that into the location it needs to go. I'm going to put a group around this, and this is going to be move to waypoint. So that's simple. Let's test this out to see if this works. So this little guy should now, I'm going to zoom out a little bit so we can see. I'm going to push play to test it. Sorry, my laptop's a little slow. Okay, we've gotten the error. What is your boggle? Okay, I made an oopsie, so let me just fix something. I did not duplicate my player controller, so I'm going to just duplicate that. Call this enemy controller. Sorry, I was working at a point where I kind of just did not think about what I was doing. So I'm going to call this enemy controller TD, top down. I hope I spelled that right. There's no guarantee that at this point. It's been one of those days. So I'm going to grab the enemy TD controller, plug it into here. I'm just going to go back to my Cuphead controller and fix this by deleting all of this stuff that I've now added for no apparent reason. Plug this back in so that this can work again. Just double check a few variables. This is good. Double check this one again. This should be fine now. So now it's using all the correct stuff. I just want to make sure everything is right again. Let's test if we get any more errors, shall we? Okay, so you'll see this little guy is cruising. Now, if you notice, he's kind of shifted weight here, so he's kind of gotten here and he's kind of gotten stuck for some reason. There's no way this is great to read. Oh, apologies. I'm having one of those days, clearly. We're going to do it the other way around. Sorry, we're going to check that against the list. Because doing it the other way around is obviously going to give us a false positive, and it's going to be very confused. Okay, so let's just get the system working, and then we'll get the animations working and get the little sprite to be correct. So now he's going to cruise, gets to that location, he moves to the next location, he moves to the next location, he moves to the next location, and it just keeps going round and round. So if your system is set up correctly, you should have this little guy going round and round and round. Okay, now the problem is, being a top-down game with the sprites, like we've got the little player, if I move the player around, you see that the sprites will actually face the direction, so I don't want the rotation to be affected. So we're going to force that rotation to be locked. So I'm just going to copy this update, and we're just going to paste it down somewhere at the bottom here. And I'm going to do a transform.rotation, simply just to freeze the rotation of the character. Not transform.rotate, apologies, don't do that. Go transform.rotation, and we're going to set the transform rotation. Now we need to just get ourselves a new quaternion XYZW, and I'm just going to say this is going to freeze rotation of enemy. There we go. So we just know that we're probably going to have to tweak some of these values. I just want to check what direction we need to set it, but it should be okay and should set. Okay, good. Now we need to, essentially I'm going to want to set it 90 degrees in the X so that it's facing up. So I'm going to put that as 90 degrees in the X. And now it's crapping out on me, so why are you not going at minus 90 maybe? No. 0. 90. Okay, so we're going to do a quick fix for this rather than just trying to do this. We'll leave this as it is because that's not a bad thing. I'm going to essentially duplicate this, what I've got here right now, and you'll see what I mean by what I'm going to do. So I'm just going to duplicate this enemy. I'm going to rename this to enemy TD for top-down sprite. And I'm going to remove everything from here that I don't need. So I'm going to remove the agent. I'm going to leave the animator because I want it there. I'm going to remove the flow graph. I'm going to remove the rigid body, the capsule collider, and just leave the sprite. And then I'm going to drag that and parent that to the current enemy. And then the current enemy, I'm going to remove the sprite renderer, and we just need essentially the character itself. So if I move this away, you'll see that there's no character. So this is the visual aid, and this is actually doing all the movement and logic behind the character. So now the character should face camera at all times. It should have faced all camera at all times. Oh, apologies. Let me rotate this back to normal and then rotate this one correctly. Sorry, I forgot that I originally rotated the base for the player. I needed to rotate the base back so that the sprite sheet will face the correct way. There we go. So now the character is moving from waypoint to waypoint. Now all the technical side stuff of it is done to some degree. So here's our entire waypoint system in working, and we've frozen the rotation so that he doesn't look in the direction he's moving. We need to update and tweak the current code that we have here for. So I'm just going to copy this update. I'm going to come down here and paste it again. We want to copy the movement that we did recently, but like I spoke about, we don't have input for the enemy to move, so we need to rebuild that. And we don't need this rigid velocity anymore either. So let's fix that first. Let's get rid of these 5 nodes here along with the new vector 3 and the velocity, and we're going to delete that. I'm going to plug this directly into the next animator that we have. Also just going to scale this down and shimmy this across so we have more, so I can see the stuff in a neater way for the sake of crazy. So we're going to move this comparison because we still need it. Now, like I've said in the last video, the reason I added this comparison is because I don't have all the sprite videos. So if we just go to the animator, just to show you what I mean, if I go into my not idle state, my locomotion, and great, it doesn't show. That's beautiful. So you'll see in the animations here, I've got 2 run rights because I could find the sprites for this Cuphead stuff for the one direction, but I couldn't seem to find the other direction. So all we're doing here is I'm going to flip the sprite. So I'm going to go down to this character. Let's go here. Sorry about the camera glitch there. And when the character is going left, I'm going to flip it, and then when he's going right, I'm going to go back to normal. So that's all we're doing in that section. So that's why, just so that it behaves the way I want it. But in order to get these values to come through, I need to add a agent.velocity, which is going to allow me to get the velocity of the agent, and then from there feed it into the actual animator. So from here we need to just get the vector 3.x, and I just need the x and the z. So I'm going to do a vector 3.z. So now that we have the x and the z, I can just plug the x into the x speed and plug the z into the z speed animator so that this section will work. Now the animator itself is broken for the flipping, so we're going to need to make a reference to where the animator and the sprite sheet are at the moment. But this flipping only needs to happen on the x. So I'm going to drag the x and plug it into a. So if a is greater than b, which is 0, it means the character is going right. If a is less than b, it means the character is going left on screen. So we just need to do that. Now let me just select my character, go to the variables, and we're going to make a reference to the sprite. So I'm going to call this enemy sprite, so we can reference the animator and all of that on that sprite sheet. And this is going to be referencing, let's just do it simple, referencing the game object. Game object is this enemy TD sprite. Then we can bring this in here. We can plug this directly into all of these. So we can plug this into the animator self. We can plug this directly into the sprites themselves. This is the sprite render flip. We're just going to put this somewhere down here where it doesn't look so messy. Okay. Actually, I'm probably just going to make a duplicate of this here so that we don't have all these crossing wires. So we'll just do this, just for cleanliness sake. We can put this back up here. There we go. Just gonna make sure that I don't have any lingering logic here, like that. The animator shouldn't be there. There we go, because the animator is on the actual sprite. So the sprite's got the animator and all of that. Okay, so that's now the movement logic. Now we're doing the idle logic, because down here, all I'm doing here is checking whether which direction the character was going in. And so when he goes right and then he stops, he's still going to be facing right. When he's going up and he stops, he's going to be looking up. So that's what that's doing. But down here, we need to check. I'm checking to see if the character's moving. And if he's moving, what to do with that. So I'm going to drag that because we don't need that again. We do not need that. And I'm going to grab these two here, the navmesh agent velocity and the two vectors that are pulled from it. And we're just going to plug that into A, plug that into B, or X and Y, depending how you want to look at it, so that we can get a magnitude value, which is a combination value out of these two, a single value that I can then reference to this value here. So if these two values are equal, that means there's no movement. But if they're not, there is movement. So in the previous video, I made an idle X float and an Z. So what I'm doing is, while I'm moving, I'm storing the movement into these two variables. And when I stop, I use those final outputs to feed which of the idle locomotion blend tree states it needs to be in. So I'm going to again make reference to my animator and my enemy sprite. So I'm going to grab my enemy sprite and I plug this into wherever the animator is needed. So into here, into here, into here, and into the last one over here. These two here need inputs, they need values, which we are just going to grab from over here, from the actual velocity. So I need the Z velocity first, then I need the X velocity for the last one. And now if I've done my job right and I've made sure everything is added, our little AI should now, if I go into the top view, turn off gizmos so we can see what's happening. And if I push play, he should just walk, the animation that plays should be the direction that he's moving. There we go. So if I make this full screen, you'll see that he's playing the correct animations. Sorry, I was trying to save in play mode, my apologies. One again. There we go. So everything is working now. So now that that's working, I'm going to end this video at this point, and then I'm going to start the next video by what happens if you get near this enemy, or this could be an NPC for all we know what this, and from there what do we do from that. So this is the end of this video. Just to recap what we've done, we just created the actual waypoint system. So we created a list of a predefined static list of waypoints. You can have this as many as you want. We could even create a dynamic one if you'd like. And we're moving to each point in this list by using this current index integer to tell us where in the list we currently are. So we start at 0, move to 1, 2, and 3. We've got the enemy sprite that we created, which is just talking to this sprite sheet here, feeding into the animator and feeding into the actual sprite sheet itself. So this top section here is saying that once you've reached your location or your waypoint, add 1 and go to the next waypoint. And then this one is just checking that once the current index is equal to or greater than the amount of items in this list, reset it back to 0, and then basically go back to 0 and start all over again. That's all we're doing in this system here. So all the movement happens down here where we move to the actual waypoint. Over here, and down here was the one thing I just wanted to freeze the rotation so that the character wouldn't look in the direction. Now if you were creating a game where you actually want the sprite to look where it's going, then don't add this section here. This section is just here for me to lock it off because I'm trying to take advantage of the sprites actually changing direction based on its movement. And then all I did in this section here is that we were using inputs to control the animator's floats. All I did was use the navmesh agent velocity, X and Z, and plug them directly into the animator floats. And like I said, this section here is not the best solution, but it's a makeshift solution so that I could flip the sprite in the direction of the missing sprite sheets that I had. Yeah, and then that's it. That is all for this video, and we'll come back in the next one.